Okay, section 9.6 involves inequalities. So before we actually get into it, I thought we might want to do an inequality review. Now, that being said, if you don't need this review, feel free to skip on to the next video. The things we're going to be talking about here are the basic rules of inequalities and how to graph inequalities. So, first thing we want to do is look at the basic inequality rules. And let's do that by first taking a look at what we do with inequalities. Let's take a look at this basic inequality. 3 is less than 5. I'm pretty sure we can agree that 3 is less than 5. So let's add 133 to both sides of this. Now what we're doing is we're seeing how this affects the inequality. If it changes it, if it makes it equal, whatever. So if we want to add 133 to both sides, if we add 133 to 3, we get 136. And if we add 133 to 5, we get 138. So we don't know what the inequality is yet. We want to take a look at this to see what it's like. So which one of these is bigger? Well, 138 is bigger, so that means 136 is less than 138. So we can say that we can still say that the left side is less than the right side. I'm going to go ahead and write that down. After adding, the left is still less than the right. So that brings us to inequality rule number 1. Okay, so inequality rule number 1 is if whoops, forgot to do the inequality rule number 1. Okay, inequality rule number 1. If A is less than B, then A plus C is less than B plus C. So that means if you can add C to both sides, and the inequality still holds. The left side is still less than the right side. So I want to write that a little bit less abstractly. So we have this is an abstract way of saying you can add or subtract to both sides of the inequality. So let's move on to the next rule. Let's go back to the original inequality that we had before. 3 is less than 5. Let's go ahead and multiply both sides by 11. And note that 11 is a positive number. So we have, when we multiply 3 by 11, we get 33. And when we multiply 5 by 11, we get 55. So the left side is still less than the right side, just like the left side is less than the right side up here. So that means that the relationship still holds. We have that 33 is less than 55. Which brings us to inequality rule number 2, which is that if A is less than B and C is greater than 0, then AC is less than BC. I have that written down wrong in my notes. So, good thing I caught that. Okay, but I don't have this written out quite the way I want to yet. So the first thing I want to say is that this is inequality rule number 2. Inequality rule number 2. If A is less than B and C is greater than 0, then A times C is less than B times C. So this is just an abstract way of saying you can multiply both sides of an inequality by a positive number. Okay, let's add a break in there. Okay, so also note I'm going to add something in. You can multiply and divide. Okay, now let's add another line break. Okay, so this applies to division as well as multiplication, as long as C is greater than 0. So let's move on to rule number 3. If that went too fast, you can scroll back and go back to the example of why that works. What if we want to multiply by something less than 0? So let's multiply both sides of the inequality by -9. So we originally had 3 is less than 5. Okay, so if 3 is less than 5, let's multiply both sides of this by -9. So that means that the left side is going to be -27, and the right side is going to be -45. So, which is bigger between the two of these? Well, 27, these are both negative numbers, which means that that we look at what we typically think of as smaller. That's probably a little bit out there in terms of how you think of it. But point that I'm getting at is that 27 is, if you put it on a number line, 27 is more to the right than 45. So that means that 27 is actually going to be larger. So that means that 27 is larger than 45. Notice that I flipped the relation now, where what was a less than is now a greater than. So whenever you multiply by a negative number, you flip the relation. You flip the sign, so to speak. So that brings us to inequality rule number 3. Okay, inequality rule number 3. If A is less than B and C is less than 0, then AC is greater than BC. Oops, forgot something. Okay, let me clear off that stuff. So if A is less than B and C is less than 0, then AC is greater than BC. So let me write that out in English. You can multiply both sides of an inequality by a negative number. Let's put a line break in there. But you must flip the sign. And I'm going to put must under in. Sorry, I'm going to underline must because it's pretty important. So if you have a is less than b and c is a negative number, you can multiply a and b by c, but then you have to flip it from a less than to a greater than. And I want to say something important about these, all three of these inequality rules, and that is that these examples are all less than, but they apply exactly the same for greater than. In fact, you can kind of see that whenever you have a greater than, okay, so if a is less than b, then b is greater than a. So that means that all of the rules are exactly the same. They apply exactly the same way. Okay, so that concludes the inequality rules. Let's go on to visualizing inequalities. Whoops. Visualizing inequalities. Let's bring that a little bit lower. Okay, so let's picture the real number line. The real number line looks like this. This is just a visualization of the numbers. So 0 is in the middle. Over here is the negative numbers. Over here is the positive numbers. So now let's picture the location of 7. 7 is going to be right here. I'm going to go ahead and erase this because it's going to get in the way. 7 is right here. And so we want to mark 7. We want to say that this... So this is a way of saying that x equals 7. Because we're just saying that where is x? X is here. If we want to say we want to point x out on the number line, and we know that x is equal to 7, we can say that there's x. But now, let's say we want to represent every number that's less than or equal to x. So that means we'd start at less than or equal to 7. So that means we'd start out at 7 and then fill in everything to the left of 7, all the way over to negative infinity. So let's go ahead and erase that too. It's unnecessary. So this is giving us everything that is less than or equal to 7. We just drew a graph for x less than or equal to 7. All I did was I said that we want to represent 7. So here was 7. What's everything less than or equal to 7? It's just everything less than or equal to 7. Okay, but what if we don't want to include 7? What if we want to show the relation x is less than 7? Strictly less than. Not less than or equal to, just less than 7. Okay, so let's go ahead and draw the number line. And we have 0 here. Well, that's a bad 0. And we have 7 here. I don't know why I put 0 on the bottom and 7 on the top. It doesn't really matter. And we want to show everything less than 7. All we would do for that is we would draw an empty circle and then fill in everything to the left. What this is saying is we're representing every single number that is less than 7, excluding 7, because 7 is not less than itself. It's equal to itself. That sounds like not quite the way I wanted to describe it, but basically what I'm saying is that this shows what we call a strict inequality. It means that this is a visual way of representing every single number that is less than 7. So 6.99999 will be on here, but 7 will not. That is the end of the review for inequalities. After this, we will be going into the actual material from 9.6, which is graphing what we call compound inequalities as well as solving inequalities. And we'll be using these rules to do that. Alright, I will see you in the next video.